5 times in 3 pages that labels all the different types of cells in that collage of a picture. I pretty much guarantee, is that here?
No.
Yeah. I pretty much guarantee you that you will see that picture with at least something once or twice on your test.
Which one? Sorry.
The one that's 5 times over 332, 333, and 334.
Oh.
Each one of those 5 pictures shows a couple different things. It shows a fibroblast, or it shows a mast cell, or it shows a plasma cell, or it shows a red blood cell, or something to that effect. Okay, so you're going to have to be able to identify all the different parts of that one picture. They could probably put a couple more on there. There's only 12 things there. It's not that many. 3 types of elastic or fibers, the different, and then the different cells that are in there. Just like, let's see, we learn about that. Oh, that's next question. Never mind. Oh yeah, it was. We learned in anatomy, type of anatomy in number 1, which was the first 8 weeks of conception. Embryology. Back in all the way to module 1. I think there were 6 different anatomies and like 8 different physiologies that you had to memorize and remember what they were. Guess what? They're going to be on the final. Yeah, I think they're on the final. But anyways, so we have, what's the first 8 weeks of conception is called? Conception to the first 8 weeks is called? It's the embryonic stage, or embryology is the study of it, okay? We have a certain tissue that all other tissues differentiate from, called ectoderm, mesoderm, and endoderm. Yeah. Every thing that you are comes from one of those 3. Mesenchyme comes from the ectoderm, endoderm, excuse me. That's not important. It's mesoderm, I believe. Mesenchyme, people don't watch this and go, I don't know what he's talking about. Mesenchyme is what?
Almost fluid consistency, and cells are widely spaced. Almost. Yeah, so it's like in the book.
Okay, what is it? That's what it's made up of.
What the embryo is made up of?
It's the connective tissue.
It's embryonic connective tissue. So your embryo, in other words, from conception to 8 weeks, is this mesenchyme. And then it's going to start differentiating into all your other connective tissue. It comes from mesenchyme. Your umbilical cord is made up of what? The other one there. Mucous connective tissue, also known as, you like to put it with your peanut butter? Orange jelly. Don't put it with your peanut butter. I made kind of a nasty tasting sandwich. So the body, the embryo, is mesenchyme. Okay, the umbilical cord is mucous connective tissue, also known as wart and jelly. That's pretty much what you need to know about embryonic connective tissue. How does that differ from adult connective tissue? Or mature, I should say. You have one tissue in embryonic through 8 weeks. How many tissues do you have as mature? Well, there's 5 categories, which each have a few different ones inside. So there's going to be a few extra above and below that. So it differentiates into a bunch of different tissues. Okay. You're going to have to be able to recognize on the connective tissue if it's categorized as loose, dense, bone, blood, or cartilage, and where it's located. Okay, so just like we did with the epithelial tissue, You're going to have to do the exact same thing with connective tissue. Okay? So the most abundant type of tissue is what? Connective tissue. Well, that's most, yes. But what is that? Areolar is part of the loose. Loose connective tissue is the most abundant in the body. Okay? It has the most extracellular matrix. That means it has more space, less cells floating around in them. Okay? Of the loose connective tissue, areolar is the most common. Okay? And where do we find areolar connective tissue? Skins, mucous membrane, and supports a lot of our organs. Okay? On the side of each one of these slides, it's going to tell you the information that you need to know about each one of these types of connective tissue. Okay, so there's not in the slide, it's actually, you have to read the study guide next to the slide. Okay. So areolar connective tissue, you might have to be able to identify these by their pictures. So that colorful one with all the different fibers in it is going to be your areolar. The one on 337 up the top, those big white sites or cells are filled with what? Fat. And what do adipose tissue do? Stores fat. What else does it do? Cushions. So it cushions a little bit. What else does it do? Insulates. Exactly. You notice that a lot of old people, even though they're in Florida, they're still wearing a sweater at 95 degrees. It's because the adipocytes would help with regulation of your body temperature in the extremities. They go away, and it all goes to the core of the body. So their arms, that's why they have the grandma flap. I'm really sad that I can do that on mine. The flappy arms, okay? Same thing with the legs, a lot of them have flappy legs. It's because that adipose that was used for tissue and that connective tissue that holds all that stuff together firm, they use all that energy up and then it stores it in the body. Okay, so in the core, because the core is more important than the extremities. You can lose an arm and still survive. If you lose a lung, it's going to be a lot harder. If you lose, the heart, because you don't have it properly energy or insulated, it doesn't do you any good. Okay, so insulation is really important. So your control of your body temperature is done through fat. So those people with 3 or 4% body fat are not healthy. Yeah.
And make it comfortable.
But yeah, put on the coat, exactly. So know that your adipocytes insulate, store energy. Okay. Your reticular connective tissue, what does it do?
Hold everything together.
Yeah, it's good. Well, not everything, certain organs. Okay, it's gonna. Yeah, who's seen a dissection? Well, first week, the lab. Did you guys see the dissection video? Mm-hmm. What happens when you pull the liver out of the body? Yeah, it went all over the place. Kind of used both hands, and it kind of went through the fingers and everything. Did it completely fall apart and out of the hand? No. What happens is a reticular connective tissue is holding that together. It's all through that liver, and it's holding it together. It allows it to, be very fluid, but it still holds it together so it doesn't fall apart. How about the kidney? You pick up a kidney, is it like the liver? No. So it has more reticular connective tissue in it than the liver has in it. So it's got.
It gives it its shape?
It gives it more of a strength. Hold it together. Okay, so think of it like the scaffolding around a building, or think of when you're building a house, you have to, you know what framing a house means? You have to build these walls, but you have to put the 2x4s every 18 inches, so that the wall has strength to it. 16 inches, thank you. 16 on center. It's been a while since I've been in construction. But yeah, so you have to have the 2x4s every so often to give that wall strength. Well, think of those 2x4s as the reticular connective tissue. It's what's giving the organs its shape or its strength so it can be held together.
It's the rebar in the concrete.
Rebar in the concrete, exactly. Okay, that's actually probably a better analysis. But it's what's going to give it the strength and to hold it together, okay? Or areolar connective tissue is going to hold everything in place. So all around the organs, going to keep the kidneys over here, it's going to keep the liver up here, it's going to keep the heart and the lungs and where they need to be, small intestine. How long is the small intestine? Anyone know? About 15 to 20 feet. All right here. All right here, okay? 15 to 20 feet. How easy would it be to wind it on itself? Everyone taking a hose and try to wind it, and when it twists on itself and it pinches the hose off? Okay, your hose has strong walls. The small intestines are very thin, so you need the areolar connective tissue in there holding them in place to keep them from rolling on each other and pinching each other off. Okay, so that's what areolar does, whereas the connective tissue would help the liver stay in its shape, the kidney stay in its shape. Okay, so it's going to help those things stay the way they should be. So that's loose connective tissue. What makes it loose? Exactly, it has more extracellular matrix. Okay, if you look on page 3 of this little handout I gave you, it tells you loose connective tissue, the 3 types, and where you'll find them. Okay, dense connective tissue, 3 types, where you'll find them. Cartilage, 3 types, where you'll find them. Liquid, the 2 types, and bone, the 2 types, and where you find those. Okay, so if you can do this and this, that's 3/4 of your test, right there on those 2 sheets of paper. Okay, so if you can, not only you need to know where they're at, but know what they are made up of. Okay, so with dense connective tissue, like we said, loose connective tissue has a lot of extracellular matrix, right? So do you think dense connective tissue has a lot of extracellular matrix? No. The fibers are going to be very densely packed, okay? So if I say dense regular, how do you think the fibers are aligned?
Organized like a pattern.
Very tight together, right? Dense, and then in a pattern, parallel pattern, okay? If I say dense irregular, okay, they're all going to be stacked really tight together, but they're going to be all over the place, right? Okay, that's the difference between dense regular and dense irregular, is just the way in which the fibers are lined up. And why would we have those 2 different ways? Why do we need dense regular and dense irregular? Right, one's going to be a little more flexible than the other. Which way do, what do dense regular, where do we find that? Tendons and ligaments, right? What do tendons connect?
Muscle to bone.
Muscle to bone. How many directions do muscles move?
Both ways. One way?
They only contract. Okay. If I do this, this is the only muscle working. This one's relaxing. When I do this one works, this one relaxes. Muscles only contract one way. Okay. So you have muscles